Okay, for part D, it says use your answers to parts B and C. I've put our answers over here to find the maximum value of R of t, and this is the function R of t, and this is the graph of R of t. So if you remember, R of t is the number of hours from the start of the day until sunrise. So it's kind of like from midnight to sunrise, and we're trying to find the maximum value of R of t. So it's like the longest night, if you want to think of it like that. So we're trying to find the maximum, which is up here. Now, this is the x-axis is the number of days, and the y-axis is the number of hours. Now, we found in part B that, well, there was this many hours in a Martian day, and that there's 2 pi, Mars spins on an axis, and obviously there's 2 pi radians in one full turn. So we divided 2 pi by this to figure out how many radians Mars spins in 1 hour. And it spins 0.255 radians in 1 hour. So the maximum value of R of t is going to be, it's in hours, and we've got our maximum value of omega. So omega is the amount of time that it spins, or sorry, it's the max angle that it can spin, depending on the tilt of the tilt of the axis. But the maximum value it can spin in that time is 1.97685. So it can spin 1.97685 radians. That's the maximum amount it can spin from the start of the day until sunrise. And we want to find out, okay, well, how many hours is that going to be? So all we have to do is do this divided by 0.255, because we know it spins that much in 1 hour, and this is the max that it spins ever from the start of the day to sunrise. So we say how many of these in this, and that will give me the max value of R of t. So that's confusing, guys. It actually took me a while to get my head around that when I was trying to do this question. So let's do that. 1.97685 divided by 0.255 gives me 7.75235. 7.75235. So that's going to be the max value of R of t. And that kind of makes sense, because remember, R of t is the number of hours from the start of the day, which would be like, if it was Earth, that would be 12 o'clock, to sunrise. So yeah, it might make sense that the longest night you're going to get would be from midnight to like nearly 8 o'clock in the morning. The minimum then will just be the other one. So the second one is the minimum. It's just going to be 1.16474 divided by 0.255, and that is 1.16474 divided by 0.255, 4.56761. 4.56761. So that's the max, and that's the min. Okay, now that I have those, it says hence show that A is equal to 1.6. Now A is the amplitude. Now we're getting back to basics. We should hopefully know how to find the amplitude. Well, there's a nice formula to find the amplitude. It's just this minus this divided by 2. So A is equal to 7.75235 minus 4.56761 over 2. So it's half the distance between the max and the min. And that is 7.75235 minus 4.56761 divided by 2 gives me 1.59237. 1.59237. And then finally, for part F, he says find the value of C. Well, C is that equation of of the principal axis. So it's like literally this value here. It goes straight through the middle. And again, there's a nice formula for that. It's the max plus the min divided by 2, because it's halfway between the max and the min. So it's 7.75235 plus 4.56761 all over 2. I am going to just copy and paste this, guys, and change the sign to plus 6.15998. 6.15998. Okay, that's parts D, E, and F.